Hello, we are at the end of the module 1. So, in this session, we will be discussing about the last topic, concentration cells. Okay, so in this chapter, we started with the Nernst equation and we studied the reference electrodes, and under that, we have studied the Calamel electrode construction and working, and then we studied the ion selective electrodes. For that example, glass electrode construction and determination of pH we studied, and then we studied the batteries classification, and under batteries, nickel metal hydride and lithium ion batteries is over, and this is the last topic, concentration cells. Okay, so here in this session we will be discussing about the concentration cells and also few numerical problems on concentration cells. Okay, so what are these concentration cells? Concentration cells are, they are of two types. Okay, so one is electrolyte concentration cell, the second one is a electrode concentration cell. Okay, what is the difference here? Let us see. The two electrodes, okay, made up of a same metal and are dipped in a same electrolyte solution of different concentrations, which forms a cell is known as a electrolyte concentration cell. Okay, electrolyte concentration cell. Two electrodes are there. Two electrodes both are made up of a same metal. For example, anode and cathode both are made up of copper. Anode and cathode both are made up of silver. Anode and cathode both are made up of a nickel. Okay, like that. Both the electrodes are made up of a same metal, which are dipped in a electrolyte of a different concentrations. Okay, until the concentrations are different, there will be a flow of electrons and hence the current. Once the concentrations become equal, there is no more flow of electrons and hence no current. Okay, so the electrolyte concentration cell, two electrodes are there which are made up of a same metal. They are dipped in the electrolyte of different concentrations. Until the concentrations are different, there will be a movement of electrons and hence current. Once the concentration become equal, there is no more flow of electrons and hence there is no current. The second type of concentration cells is a electrode concentration cells. Okay, in this type of electrode concentration cells, two electrodes are there. They are made by using different compositions of a metal. Okay, for example, they are made by using two metals. You think two metals they are made by. Okay, the compositions of the metal taken will be different here, and they are dipped in the electrolyte solution of same concentrations. I think you understood. Okay, here no two electrodes are there. They made up of different compositions of the metals. They are dipped in the electrolyte solution of same concentrations, which forms a cell which is known as a electrode concentration cell. Okay, in our syllabus we have electrolyte concentration cell. Okay, so here the diagram will be like this. The concentration cell diagram will be like this. Here two copper electrodes are shown here. Two electrodes made up of a copper. They are dipped in the solutions of 0.01 normal and 0.1 normal solutions. Okay, see the concentrations of the solutions are different. Once until the concentrations are different, there will be a movement of the electrons from anode to cathode. Once the concentrations become equal, okay, there is no more flow of electrons and hence no current will be there. Okay, so you will writing the diagram, you have to write two electrodes. Okay, they are dipped in a solution of same electrolyte of different concentrations. The both are connected to the voltmeter. Okay, and coming to the explanation part, the concentration cell, I already said the metals are dipped in the solution of its own electrolyte but of different concentrations. Forms a cell is called as a concentration cell. Okay, here the own electrolyte in the sense copper will be dipped in a copper sulfate solution. Silver will be dipped in a silver nitrate solution. Nickel will be dipped in a nickel sulfate solution. They are called as its own electrolyte. Okay, two electrodes made up of a same metal are dipped in the solution of its own electrolyte but of different concentrations forms a cell is called as a concentration cell. Okay, here flow of electrons is seen until the concentration is different. Once the concentration becomes constant or equal, there is no more flow of electrons and hence no current. The above concentration cell consists of a diagram what we have seen now. Two electrodes made up of copper. They are dipped in the copper sulfate solutions of different concentration 0.01 and 0.1. Okay, fine. And coming to the cell reactions here, at anode we know very well oxidation takes place. So Cu gives Cu2 plus 2 electrons, and at cathode what happens? Copper ions are there. They accept the electrons liberated at the anode and gets reduced to the copper. Okay, so we cannot write the net reaction. Okay, net reaction is 0 here. Okay, fine. When C1 is equal to C2, that is when the concentrations become equal, the EMF will become 0. Okay, and the potential of the concentration cell is given by the Nernst equation. E is equal to 0.0591 by N into log of C2 by C1. This formula you will be using when we do the problems on concentration cells. Okay, and you must write here where C2 is greater than C1. Okay, higher concentration is always you have to take in the numerator, and the lesser concentration is a denominator. Okay, C2 is greater than C1. Okay, and applications of the concentration cells are, the concentration cells are used in the determination of the valency of ions, and they are used in the determination of a transport number, and they also are used in the determination of solubility of the some sparingly soluble salts. These are about the applications of the concentration cells. Okay, let us see some few problems on concentration cells. See, for a concentration cell, cell representation is given here. Tin per tin ions. Okay, salt bridge. Tin ions per tin. Develop a potential of 0.0126 volts. The concentration of the solutions are 0.064 and 0.024 molar. Calculate the valency of tin. Okay, so you write the data first. C2 you write 0.064 molar, C1 is equal to 0.024 molar, and given the potential E is equal to 0.126 volts. Okay, write the formula now. E is equal to 0.0591 by N into log of C2 by C1. Substitute all the known terms. Okay, potential is given E, that is 0.0126 and 0.0591 by N. You don't know N. Okay, here you are asked to determine the valency. So you don't know the valency, right? So you have to write N as it is. Log of C2 by C1. C2 is given as a 0.064. C1 is a 0.024. Okay, when you calculate, you will be getting the final answer as N is equal to 1.99. That is rounded off to 2. Okay, so the valency of the tin is a 2. Okay, so one of the application is fulfilled. Okay, what are the applications of the concentration cells? They are used in the determination of valency of ions. Okay, next one more problem, simple problem. A concentration cell is formed by dipping 2 silver electrodes in 0.054 and 0.01 molar silver nitrate solutions. Write the cell reactions and calculate the EMF of the cell. Okay, first you have to write the cell reactions always. Okay, usually to confuse the students, they will be giving most and many problems on silver only. Okay, here usually you will be writing Ag gives Ag2 plus. Okay, without thinking the student will be writing Ag gives Ag2 plus. Please to remember the valency of the Ag is +1. Okay, so you can write only Ag gives Ag plus electron. You cannot write Ag2 plus. You can write, when you can write, okay, if you want to write Ag2 plus, you have to write 2 moles of Ag here. 2 Ag gives Ag2 plus. That will be correct. Okay, so Ag gives Ag plus electron at anode, and at cathode, silver ions accept the electron to become silver. Okay, and then write the formula. E is equal to 0.0591 by N into log of C2 by C1. Okay, so here E is equal to 0.0591 by 1 into log of 0.1 by 0.054. It will be giving rise to 0.0158 volts. Okay, so this is the EMF produced when 2 silver electrodes are connected. Okay, so like this problems will be asked in the exam. Fine. So the important key points in this session are, what are concentration cells means? Concentration cells are 2 electrodes dipped in the 2 electrodes made up of a same metal are dipped in the same electrolyte solutions. Okay, or you can write its own electrolyte solutions but of different concentrations forms a cell which is called as a concentration cells. Okay, until the concentrations are different, okay, there is a flow of electron and hence current. Once the concentrations become equal, there is no more flow of electrons and hence there is no current. Okay, and we don't have a electrode concentration cells, so nothing to worry about it. Okay, we have in our syllabus only electrolyte concentration cells. Okay, if it is asked in the diagram part, you can take any metal as an example. Okay, any metal, the concentration cell is made up of any metal. You can show silver, copper, magnesium, nickel, chromium, anything. Okay, both the electrodes are made up of same metal dipped in the solution of same electrolyte but of different concentrations. Okay, write the anodic and cathodic reaction. You cannot write the net reaction here. Okay, you can write only when C1 is equal to C2, the EMF will become 0. Okay, and always you must write C2 is greater than C1. Okay, one concentration is more and one concentration is less. No, so you must write there where C2 is greater than C1. Okay, so this is the last topic of this chapter. We will be meeting with the next chapter and next topic. Okay, until then, take care. Thank you.